The following table contains data collected in an experiment in which the length of an elastic band is measured when different masses are suspended from it. What are the independent and dependent variables? Graph the data on the grid provided. Write an equation to relate the length L of the elastic band to the mass m that is suspended from it. Use the equation to predict the length of the elastic if a mass of 750 grams is suspended. The independent variable represents the values that are chosen in an experiment. It is always plotted along the x-axis and usually is listed first in a table of values. The dependent variable are the values that are measured at chosen values of the independent variable. It is always plotted along the y-axis and usually listed second in the table of values. For this question, we have to label and scale the axes, making sure we use up most of the grid that is provided. We then plot the points. From the points, we can determine the slope and the y-intercept. We can then express in slope-intercept form. Y equals mx plus b, where m is the slope and b is the y-intercept. In this case, the independent variable corresponds to m, the mass that is suspended. The dependent variable corresponds to L, the length of the elastic band that is measured. We can then label here the independent variable along the x-axis, the mass in grams, and the dependent variable along the y-axis, length in centimeters. We then have to scale the axes. First of all, the mass. Note that the mass goes from 0 to 1000, and there are 11 divisions on the grid provided. That means we can use 100 grams per division for the scale. For the length, note that it goes from 6.5 to 14, and again, there are 11 divisions. This means we can use 1 centimeter per division. Recall that it is not necessary to include the origin on the graph. We can then plot the points. 0, 6.5, 100, 7.3, 200, 8.0, 300, 8.8, 400, 9.4, 500, 10.0, 600, 10.8, 800, 12.1, and 1000, 13.6. Draw a line through these points. Note the arrow only on the right side, since the mass here cannot be negative. We can then figure out the slope. To do this, we need 2 points on the graph. Let's pick this point and this point. Recall that slope is equal to the change in the y-coordinates, 13.6 minus 7.3, divided by the change in the x-coordinates, 1000 minus 100. This gives a result of 0.007 centimeters per gram. The y-intercept we can get directly from the graph, the point at which x equals 0, or in this case at which m equals 0. This corresponds to b equals 6.5 centimeters. We then have the equation in slope-intercept form. L equals 0.007 m plus 6.5. Note we're simply substituting in the slope and the y-intercept. For a mass of 750 grams, we simply substitute 750 in place of m. L equals 0.007 times 750 plus 6.5. This gives a result of 11.75 centimeters for the length of the elastic when 750 grams is suspended from it.